Okay, so let's continue with our matrix. So in this video we'll be talking about determinant of a matrix. Determinant. Okay, now if today is your first day of watching, please consider subscribing, or if you have not subscribed, please subscribe to encourage us do more. Okay, now before you talk about the determinant of a matrix, first of all, I think that matrix should be a square matrix first. It must be a square matrix before you can get the determinant. The same way we did in trace. Okay, the trace of a matrix. That matrix must be a square matrix before we can get the trace. So the same thing is applicable in the determinant of a matrix. Okay. So now, for one by one matrix, the determinant, if I have that matrix A, is simply 3. For example, matrix B is simply -2. The determinant of A, look at how we write it, is simply that 3. The determinant of B is simply that what? That -2. So, but in 2 by 2 matrix, for 2 by 2 matrix, we'll do it up to 4 by 4 matrix. So the second one is for 2 by 2 matrix. Okay, if A is equal to 2 by 2 matrix, I'm having maybe 2, 3, 4, 5, and then B is equal to maybe -6 to 0, 1. Okay, now the determinant of this is just left minus right. Just no left, right, that's all. So the determinant of matrix A is simply left, right. Don't say like right, left, you have failed it. Left first before right. So this time this will give you what? 10 minus this time this, you have what? Let's get C. C is equal to 2 minus 3, 1 and 4, for instance. Okay, so left like this first before right. This time this 10, this time this will give you 12. So what do I have now? -2. So determinant of B left again. This time this -6 minus this time this 0, which will give you -6. Determinant of C is what? Left before right. This time this will give you what? 8. Original minus before you say this time this, which will give you -3. Okay, so which will give you 8 plus this, which is what? 11. Okay, as simple as that. Now let's move into determinant of 3 by 3 matrix. Determinant of 3 by 3 matrix. For 3 by 3 matrix, okay, we have that A is equal to let me choose any. For 3 by 3 matrix, okay, for 3 by 3 matrix, in fact they can ask you to find the determinant of 2A minus 3B. I hope you know. First of all you have to find that 2A minus 3B, then get the determinant. It's not difficult. So that is that. So let's take a question for determinant of 3 by 3 matrix. Okay, we have 2, 7, 3, -4, 0, 7, 5, 0, 1. Okay. Now in the determinant of this 3 by 3 matrix, it's not difficult to get. What do you do? I'm going to solve just one simple example, or two rather. I will just put for me plus, minus, plus here. Okay, so let's go. Now this is the determinant of A is simply all the ones at the top are just for picking. So I'm picking this one 2. Then if I pick it, close everything under it and then know what is remaining. What is remaining is 0, 7, 0, 1. Okay, then the next one you are picking is what? -7. Remember that everybody on top is just for picking, so close everybody under the one you are picking. So you are left with what? -4, 7, 5 and 1. Okay, the next one you are picking is what? Plus 3. So if you close under the ones you picked, you are left with what? Minus 4050. Okay, so that is that, and then you are done. So my answer is now 2 is here. Remember how we do this one? This is now 2 by 2 matrix, left, right. So you say left this time this 0, minus right this time this 0. You now bring down your minus 7 in bracket of this time this you have what? Minus 4. Then the original minus this time this you have 3 times 6 18, 3 times 7, sorry, 35. Okay, so what do I have? Plus 3 left again, right? Anything times 0, 0 minus 0. So what do we have now? We are having 2 bracket 0 minus 7 into minus 39. Okay, then plus 3 into 0. Okay, so what do we have now? 0 plus 7 times 39. I hope you know why we have plus, because minus minus is plus. Then 7 times 39 will give you 273. Okay, then plus 0, which is 273 as my last answer. Okay, so you see, it's very, very simple. So now what do we do now? Okay, so now the next thing we will do now is, now the reason I did this thing is because I am teaching it. If you want to get the answer very fast, determinant of A is simply, just know that everybody at the top is just for picking. So you say plus 2 in bracket of, then close here and just go straight here and do the left, right. 7 times 0 is 0, minus 7 times 0, 0 times 1 is 0, 7 times 0, 0. Okay, you see, I'm now at this line instead of writing this one. So bring down minus 7. Everybody here is for picking. Close it. You're having minus 4 times 1, which is what? Minus 4, minus 7 times this, which is 35. Okay, then the last one you're picking is plus 3. Then close everybody under plus 3. Do your left, right again. Left, right. Minus 3 times 0 is minus 4 times 0 is 0, minus 0 times 5 is 0. So my answer finally becomes this minus this 0, 0 times anything is 0, minus 7 into minus 39, and 0 times anything is 0. So my answer finally becomes 273 without going through all this process. Just know that if you just pick, close it and do your left, right, that's all. So that is the first way of solving it. There's another alternative way of getting only 3 by 3 matrix. Okay, there's another alternative way of getting only 3 by 3 matrix, and that alternative way is very, very simple. So what do? Just write this thing out. Write it out like this: 2 7 3, then 2 and 7 again. Just there will be 5 numbers: 2 7 3, then repeat the 2 and 7 again. The same thing here: minus 4 0 7, then minus 4 0. Okay, then the last one is what? 5 0 1. Then what do you do now? Minus 5 again 1. Okay, so now draw the diagonals the way it will be. You know that this one started from here like this. Very simple. Okay, there will be 3 in number. Then the next one is to move the other way. So let's move the other way. I'm moving like this now. Okay, is there another one that can be tried? This one.
I'm okay with it.
Okay, so once you are done like this, you'll be left with these 4. These 2 will now be left out. So your answer is simply the one that comes down like this is positive. The one that is going up is negative. So I'm going to have multiply it. So my answer will now be watch, the determinant of A will now be what? 2 times 0. 0. 0 times 1. 0. I'm having 0. Okay? Plus, let's do it again. 7 times 7. 49. 49 times 5. 49 times 5. I'm having 245. 245. Okay? Then the next one, I have done this one. I told you that all these ones are positive. But this one coming here and negative. So the last one, 3 times 4. 3 times minus 4 is minus 12. Minus 12 times 1 is minus 12. Okay? Then I'm done with the positive. So let's go to the negative. So this one is positive, but the other one is what? Negative. So I'm going to have, or let me just say it started with negative. Minus times this, minus 5. Minus 5 times 0. 0 times this is 0. So I'm having 0. Minus times 0. In fact, since it's 0, everything is 0. Okay? But look at here that we don't have 0. Minus 1 times 1 is minus 1. Minus 1 times minus 4 is plus 4. Plus 4 times this is 28. So let's see what this will give us if we will get the same answer. So I'm having minus 12 plus 28. I'm having 261. It's not the same answer. So with me, there's a problem somewhere. Let's check where the problem is. This one is always very confusing, and I don't like using itself. So just know the normal method that we used before. So let's do 4x4 matrix. Let's do a 4x4 matrix, and that is the highest they can ask you. 4x4 matrix. Nobody will ask you above 4x4 matrix. So they say that A is equal to matrix of 3 minus 2 1 1. So we have 2 1 0 1 minus 1 2 minus 1 1 1 2 minus 3 1. Okay, so this is this. So what do we do now? Watch, we'll reduce it first to 3x3 matrix. So I have A. The determinant of A is what? Don't forget that everybody at the top is what? Is just for picking. So what do we do? Everybody at the top is just for picking. So what do we do now? So we're going to have the what? Plus, minus, plus, minus. So we pick. If I pick what? If I pick 3, okay? If I pick 3, I close everybody under 3. So I'm left with 1 0 1, 2 minus 1 1, 2 minus 3 1. I'm left with this. Okay, the next person I'm taking is what? Minus into minus this, which is what? Plus 2. Okay, minus into minus the plus 2. Then I'm left with, if I close here, I'm left with 2 0 1 minus 1 minus 1 1 1 minus 3 1. Okay, the next one I'm picking is what? Plus 1. I pick plus 1, I'm left, and close this place. I'm left with 2 1 2 1 1 minus 1 2 1 1 2 1. So lastly, minus 1 in bracket of, if I close this one, I'm left with 2 1 0 minus 1 2 minus 1 1 2 minus 3. Okay, so and that is that. I hope you still remember how to do this. So the same thing we did, solve this one, solve this one, solve this one, then add everything together. That is your 4x4 determinant of your 4 by 4 matrix. Now there are some properties of determinant of a matrix that you need to know. So you can solve it and drop the answer at the comment section. Okay, so do that and tell me what you think the answer is at the comment section. So the next thing we need to look at is properties of a matrix of determinant. Properties of determinant. Okay, now the first property of determinant matrix is if A be a row whose entries are all zeros, then determinant of A is what? Is 0. Okay, once you have that there is a row that all the entries are 0, then we now say that what? The determinant is 0. For example, if I have that A is equal to maybe I have 2, 5, 6, and then anywhere I like, and I now saw 0 there, 7, 2, 5. Once I'm seeing 0 in straight in a row complete, then the determinant must be 0. You don't need to solve anything. The determinant must be 0. The same thing is applicable if I see that all the columns are 0. For example, I have 1, 2, 3, 0. Okay, let me say 4, 2, 5, 0, 0, 0. You see that I discovered that all the rows all the columns of a particular column are just 0. So what does it mean? That the determinant of that matrix is 0. You don't need to solve anything. Okay, these are some properties you need to know. So the next property number 3 says that what? If two rows of A are equal, then the determinant must be 0. Okay, so that's another one. When we have that the two rows are equal, for example 2, 3, 5, maybe 7, 8, 9, then 2, 3, 5. Okay, once you have that two rows are equal, the determinant must be 0. The same thing is applicable if we have that two columns are equal, two columns being equal, 1, 2, 3, 4. Okay, maybe another 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. Once you have that A is equal to this, and you are seeing that two columns are equal, automatically what you have, the determinant of that matrix is still 0. Okay, you need to note that. Very, very important. Another one, you need to know that if A is a triangular, either lower or triangular matrix, the determinant is simply the product of the entries in the leading diagonal. Okay, so what do we mean by that? That is, can I clean? Okay, number 4. Don't forget the types of matrix we have. There's a type of matrix that is called upper triangular or lower triangular. Once that matrix is an upper triangular or lower triangular matrix, okay, it means that what? The matrix, the determinant of that matrix is simply multiply all the diagonal. That's all the leading entries of the diagonal. Okay, it must be a leading entry. What do we mean by leading entry? Don't forget that leading entry can never be 0. But if the leading entry has 0, then automatically it's going to be 0, because 0 times, in fact, multiply all the leading entries. Don't add the 0, just multiply all the leading entries. It cannot be 0, just multiply all the leading entries. What do I mean by that? Look at this. I have 1, 0, 0, 2, 3, 0, 4, 5, 6. Now I have this. If you look at this, this is what I told that whenever the upper triangular is 0, this matrix is called what? A lower triangular matrix. I hope you know. This is a lower triangular matrix. So the determinant, if A is equal to this, the determinant of this matrix is simply for us to multiply this 1 times 3 times 6. As simple as that. And that is your answer. 3 times 6 is what? 18. And that's all. So you don't need to start stressing yourself. The same thing is applicable if it is what? A lower triangular. 1, 2, 3, 0, 4, 5, 0, 0, 6. Something like this. If you look at this now, you are seeing that what? Look at the diagonal. And since the lower triangular is 0, it is what? An upper triangular matrix. So what do we have? The what? The determinant of this matrix, if this is matrix A, is simply for us to multiply the diagonal, which is 1 times 4 times 6, which is what? 24. As simple as that, okay? So the next one, this is the fifth one, the fourth one. So the fourth one has A and B. So the fifth one, now if you cannot remember all these laws, what do you do? Simply do the magic, the matrix ahead. Simply do the matrix, okay? So the next one we're talking about is let B be the matrix obtained by interchanging two rows, okay? Interchanging two rows or column of A. Then matrix B, determinant of B is simply the negative or determinant of A, okay? Now if I have two matrices, maybe A is equal to maybe 2 3 5 1 7 2 3 2 1, okay, and then I'm having that B is simply just interchange maybe a 2 row or 2 column. Maybe let me carry this one and put here, carry this one and put here. 1 7 2 2 3 5, then 3 2 1. What are they saying? That the determinant of A must be equal to what? Negative of the determinant of B. So you don't need to solve anything. If you have already gotten the determinant of A and you saw that B is gotten by either interchanging the row or interchanging the column, so you just know that the determinant will just be the negative of it, okay? So which means if the determinant of A here is -2, the determinant of B is going to be 2. If the determinant of A is 5, the determinant of B will be -5. So another way is if I have that A is equal to 1 2 3 4 5 6 7 8 9, something like this, and then B is equal to 2 5 8 1 4 7 3 6 9. If you look at this, you see that they just interchanged a column. So since a column is just interchanged, my determinant of A must be equal to the determinant of B, negative, okay, the negative of the determinant of B. So these are little things you need to know about matrix. So that is that. Another thing you need to know is that the determinant of transpose of a matrix is still equal to the determinant of that matrix, okay? Don't forget how to get transpose. Transpose means turn it, carry the row and make it to become column. That is transpose. So the determinant of it is they are the same, okay? So the next thing we'll talk about in our next video will now be inverse of a matrix. Inverse of a matrix. Okay, another thing you need to know about determinant is that whenever the determinant of a matrix is 0, it means that what? The inverse does not exist. The inverse does not exist. So which means if the determinant of a matrix is not equal to 0, it means that the inverse of that matrix exists, okay? So thank you very much for watching. God bless you. In our next video we'll now talk about inverse of a matrix. Please don't forget to subscribe.